Hello, my name is Karim Fahmy. I'm a research assistant at Fraunhofer Institute for Solar Energy Systems, and today I'm going to be talking to you about the APV-Bot demonstrator. Let me just start with a quick overview of the agenda. I'm going to start with the classification of agrivoltaics, then the motivation behind developing the APV-Bot, then an overview of the FarmBot, then how we further developed that into an agrivoltaics bot, and to conclude with, I'm gonna give a quick outlook of what to expect in the future. So what is agrivoltaics? Agrivoltaics is defined as a type of dual land use where energy production from solar PV panels and agricultural production occur on the same piece of land. We can further split agrivoltaics into open and closed systems. In the closed systems, we have PV greenhouses, and in the open systems, we have interspace photovoltaics or overhead photovoltaics. We can further look into the module layout. So they're either fixed or equipped with a tracking mechanism, either on a single or dual axis. And the typical applications range from grassland farming to aquaculture. The red box highlighted here in the middle is where the APV-Bot falls into. So it's mainly used for horticulture, so for the cultivation of fruits and vegetables. So what is the motivation behind developing the APV-Bot? So first of all, there are no more use of heavy agriculture machinery. Therefore, can have a lower height of the agri-PV system and therefore lower costs for the substructure. Further on, we looked at the substructure, and it's a suitable infrastructure for the suspension and rails of the bot. Further on, it has the potential for intercropping to increase biodiversity. The FarmBot is also equipped with automated weed removal. Thus, also we can have a 24/7 plant monitoring and protection. So a brief overview of the FarmBot. It's a fully automated CNC farming device. It's the one highlighted in the red circle on your right-hand side here in the picture. The one we procured here at Fraunhofer ISE is the Genesis version 1.5. It has a maximum growing height of 0.5 meters, which is limited by the bot's movement in the z-axis, so up and down, and also by the substructure and the modules mounted on top. The maximum growing area is 1.9 times 3 meters. And the APV-Bot can be controlled through a web-based interface, the FarmBot web app. There you can control all basic movements of the FarmBot, so moving forwards and backwards. You can also give the FarmBot commands of what kind of seeds you want to plant, where you want to plant it. You can also set up an irrigation schedule, and therefore, as mentioned in the slide before, know exactly what's happening to your plant. So also a very effective plant monitoring system. So how did we develop it to an APV-Bot? So as you can see in the picture here, we added the substructure with modules on top. And if we have in mind the classification of agrivoltaics before, this falls into an agrivoltaic system. The one showed here was built back in 2021 in Freiburg, Germany at the ISE headquarters. The crops we planted were herbs, radishes, Swiss chard, and kale. The mounting structure has a dimensions of 3 by 2 by 2 meters, and we used aluminum for that. And also we integrated a rainwater drainage system. So on the modules on the right here, there are some small rails which effectively move the water away from the bed underneath and back into the soil, since there is a known problem with water accumulating on the module edges and causing plant damage. The total system capacity is 0 kilowatt peak. The modules we used in this version were just for demonstration purposes and were semi-transparent glass modules. So now I come to my final slide. What is the outlook, the next steps? So we deconstructed the FarmBot and looking at retrofitting it with new modules that produce electricity. And the idea behind this that we want to showcase a completely off-grid system. So we're going to equip it also with batteries and upgrade the rainwater drainage system to a rainwater harvesting system. So all the precipitation that falls within the rails will be collected centrally, and with a solar energy pumping system, this water will then be transferred to the APV-Bot, which can then use it for irrigation purposes. Further on, we want to fully integrate the APV-Bot with the substructure to achieve material savings and have a cleaner look. Thank you for listening. I hope this was interesting, and I hope to hear from you soon.